Now we are going to another definition. Consider A is in BLH, where H be Hilbert space. H is Hilbert space. Now, this A is said to be normal. A is said to be normal. It's a normal operator if A star or A star A equals A star or A star equals whatever. A star A equals A star. A star equals A star E. A is a normal operator. Similarly, now we are going to another definition. This A is said to be unitary operator if A star equals I equals A star E. This is unitary. Hermitian or self-adjoint A star E. So listen, an operator A following BLH is said to be normal operator if A star equals A star E. It is said to be unitary operator if A star equals I equals A star. So from these two, immediately we can conclude that a unitary operator always become a normal operator. A unitary operator always become a normal operator, but a normal operator need not be a unitary operator. A unitary operator, A star equals A star E, so unitary operator is always normal, but a normal operator is need not be unitary. Again we are going to this definition. You consider A star equals identity. We know if f and g are any two functions having same domain, then if is a function, then there exists another function g such that f composition g equals I. Then this g is said to be the inverse of f. In the light of that argument, A is any bounded linear operator on H. A star is adjoint such that A star equals I. So this implies this A star is acts as the inverse of A. Here A star equals A inverse. That is, when an operator is unitary, then the adjoint of that operator is nothing but inverse of that operator. If A is unitary operator, then A inverse is nothing but adjoint of A inverse is A star. This is an important idea. If A is a unitary operator, then A star equals A inverse. Okay. So if A is unitary, then A should be normal. If A is self-adjoint, then A is also normal. Why? Suppose A is self-adjoint. A is self-adjoint means A star equals E. A star equals E. Then if A is unitary, surely A is normal. If A is self-adjoint, A is also normal. A is also a normal operator. Why? A is self-adjoint means A star equals A. So what is A star? A star equals A means A star into A inverse equals identity. Okay, if you multiply on both sides with the A inverse, so A star A inverse equals A inverse. A inverse is identity. That is A star A inverse is identity. A star A inverse is identity means this A inverse is so clearly this A star A inverse is identity. That is A inverse is A star means it is unitary, so it is also normal. Okay, but normal operator need not be self-adjoint. Normal operator need not be unitary. Also, normal operator need not be self-adjoint. Self-adjoint operator is normal, but normal operator need not be self-adjoint. So far, come to an example. Put A equals 2I into I. 2I. Clearly, I is an identity operator. So what about A star? A star means 2I bar. Actually it is. So it is minus 2I. Sorry, minus 2I into A. Okay. What is A star? A star equals some 4i. 2i into minus 2i, 4i square minus 4i square is 4. So it is 4i. Similarly, a star a equals also 4i. So a star a equals a star. Clearly it is normal. But what is a? A equals this one, a star equals this one. Clearly a not equal to a star. So a is not Hermitian, means not self-adjoint. So a normal operator need not be a self-adjoint operator, but a self-adjoint operator is always normal. A unitary operator is always normal, but a normal operator need not be unitary. Okay. Now we are going to a research, that is there is a theorem. Let A fall in BLH. A fall in BLH, where H be a Hilbert space. A is unitary. A is unitary if and only if norm AX equals norm X. Norm AX equals norm X. In particular, norm A inverse X equals norm X. If A is surjective, means A is onto, then in particular norm A inverse X equals norm X for all X fall in X. And norm A equals 1 equals norm AX. So this is our another research. Come to the proof. First, suppose that norm AX equals norm X. If possible, norm AX equals norm X. First, suppose that norm AX equals norm X. Consider norm AX square minus norm X square. Surely norm AX equals norm X. So consider norm AX square equals norm X square. Sure. Okay. So what is norm AX square minus norm X square? Surely it is 0. So this equals inner product AXX. Norm AX square means inner product AXX, and norm X square means inner product XX. Agree? But norm AX equals norm X implies 0 equals this one. So this is inner product AXX minus inner product AXX minus inner product AXX minus inner product AXX plus inner product minus inner product AXX. Okay, so inner product AXX minus inner product XX. Now consider this 0 equals inner product AXX minus inner product XX. Inner product AXX minus means inner product A star AXX. Inner product AXX means inner product A star AXX minus inner product XX. So that means this is inner product A star A minus identity of XX. Okay, so inner product A star A minus I XX equals 0. That should implies A star A minus I equals 0. That means A star A equals I. So A is unitary. Okay. Similarly, this can be rewritten. Again, this A star AX, inner product AXX. Again, this inner product AXX is nothing but it is inner product X A star of X. Here, yes, A star of X. Thus, we can show that A star, or replace A by A star, you can show that A star equals I. So when A star A equals I and A star equals I, clearly A is a unitary operator. Okay, A is unitary. Now for the reversing version, if A is unitary, reversely assume that if A is unitary, A is unitary means A star equals identity equals A star E. Okay. So now to show that norm AX equals norm X, consider inner product AX minus inner product XX. equals inner product. This is A star A x x minus inner product x. Okay. Then equals inner product A star A minus identity of x x. Since A star A equals identity, this equals 0. That means inner product axx minus inner product xx equals 0 means inner product axx means norm x square minus norm x square equals 0. That should implies norm ax equals norm x. So this is the reverse solution. Okay. Right. Now, in particular, if A is surjective, norm A inverse equals norm x. A is surjective, so we know when A is unitary, if and only if norm Ax equals x, norm x. And A is surjective. Also A is unitary means A star equals I implies A star equals A inverse. We know when A is unitary, A inverse is A star. Okay. So what about A star? A star equals A star into identity equals, or yes, in particular if A is surjective, then norm A inverse x equals norm x. So norm A star equals norm A inverse. So clearly norm Ax equals norm x implies norm A star x is also norm x. Why? Because A is unitary, then and A is the self-adjoint, so norm A star x equals norm x, but A star is A inverse, so norm A inverse x equals norm x. Norm A inverse x equals norm x. So norm A equals 1 equals norm A inverse. Okay, immediately taking supremum on both sides.